All right, today we're going to find the integer solutions to these two equations. And we will start out by making a little assumption, and we can make this assumption without loss of generalization. We can assume that A, B, and C is greater or equal than 0. And we can do that because if we look at A squared, well, that's the same as minus A squared. So if I have a solution A, then I know that minus A is a solution as well. So if we figure out that A is 8, well, we know that minus 8 is a solution as well. So we will make the calculations with A, B, and C greater or equal than 0. And then we'll notice that if I have A squared minus B squared, it's 21, and more generally it's greater than 0. And because it's greater than 0, I can add b squared on both sides without changing the unequal sign. So a squared is greater than b squared. And because that's greater than b squared, well, then a is greater than b, again, because we have assumed that a, b, and c are greater or equal than 0. Right. Okay, and if we look at b squared minus c squared, we can see that that's greater than 0 as well. More specifically, it's 20, and that's greater than 0. And if we add c squared on both sides, then we get b squared, which is greater than c squared. And again, we have positive numbers, so we know that b is greater than c, which is greater or equal than 0. Now, if we look at b squared minus c squared, and we write that up, b squared minus c squared, we know that that can be written as b minus c multiplied by b plus c. So b is positive, and c is positive, and c is less than b. So we know this parenthesis is positive, but we also know that it's smaller than this parenthesis because both are positive numbers. So we know that b minus c is smaller or maybe equal to b plus c. And we also know that this has to be 20. That was the assumption when we started the assignment. B squared minus c squared equals 20. So we have to figure out which numbers do I multiply together to get 20. And remember, we have integer solutions, so the parentheses will be integers as well. So if we first assume that this is 1, this is 1, then this must be 20. If we assume that this is 2, then this must be 10. We can assume this is 3, but this will not give an integer solution to this. So I will cross this over, and then we can look at 4, and if I have 4, this parenthesis will be 5. So these are the 3 possible solutions to these parentheses when it needs to be 20. And if we look at these 3 solutions, we can try them out and say, well, if we have b plus c plus b minus c, this is just something I write up to see what happens. If I see this parenthesis plus this parenthesis, 1 plus 20, that's 21. And if I look at this, I will see that c cancels out with c, so that this gives us that 2b equals 21. So b equals 10.5, which is not an integer. So this is not a solution either. We cannot use this. Let's try with the next one. 2 and 10. Again, if we add these parentheses, we will get 12, which also tells us that b equals to 6. So if we look at this, we can see that b is 6. 6 squared is 33, and this needs to be 20, so 36 minus something squared equals 20. That must be 16, and C must be 4. Okay, so this is a possible solution. We do not know if it's a solution yet, but it is a possible solution. Now, if we look at this, then we have 5.4, that's 9, so 2b equals 9, and that gives us that b equals 4.5. And that's not integers, so this is not a solution as well. So the only possible solution is b equals to 6 and c equals to 4. Now remember, we also need that a squared minus b squared equals 21. So a squared minus 36 must be equal to 21. So a squared must be equal to 55. There are no integers where this is possible, so there are no solutions to this problem. Well, the solution here was that there are no solutions. If you want to watch a video where there are solutions, please click on this link over here where I solve another problem on simultaneous equations. If you have a better solution to this problem, please let me know in the comments.